Hi students, today we are going to learn about equivalent circuit of transformer. Transformer, it transfers electrical energy from one circuit to another without changing any frequency. So here AC supply is given to primary winding and the current flows in the primary winding is I1. The number of turns, the induced EMF and the flux in primary winding is N1, E1 and Phi1. And the number of turns, induced EMF and the flux in the secondary winding is denoted as N2, E2, Phi2. Okay, and here it is secondary winding is connected to load and the current flows in the secondary winding is I2. And now by using the ideal transformer, I have drawn the equivalent circuit. So in the secondary winding, it is connected to load impedance, that is ZL. Okay, and the resistance and reactance in secondary winding is R2 and X2, and combining R2 and X2 we will get the impedance that is denoted as Z2. Okay, the voltage in secondary winding is V2 and the induced EMF in secondary winding is E2. And when we go to primary winding, when we take the no load condition, the current flows in the no load condition is I0. This I0 splits into two components, that is IW, I mu. And the resistance and reactance in no load condition is R0 and X0. Okay. And in primary winding, the resistance and reactance is R1 and X1, which is combined with the impedance, that is Z1. Okay, as I said in the previous video, for load condition we have, it draws, this primary winding draws extra additional current that is denoted as I2 dash. Okay, and the supply voltage in the primary winding is V1 and the current flows in the primary winding is I1. Okay, so here this is the complex equivalent circuit of transformer. So to simplify this circuit, we go for some conditions. Okay, we will see the different conditions to simplify this equivalent circuit. That is, first condition is transferring resistance or reactance from primary to secondary. We have to multiply the terms by K square. Okay, if you want to transfer the resistance or reactance from primary to secondary, means we have to multiply it by K square. Okay, and then transferring resistance or reactance from secondary to primary means we have to divide it by K square. And the third condition is, if you want to transfer voltage or current from one winding to another, means we have to divide by K. Okay, these are the three conditions if you want to transfer, either we want to transfer primary to secondary or secondary to primary. Okay, these are the three conditions. And now we will consider, we are going to transfer the secondary component, secondary to primary. Okay, if you want to transfer the components secondary to primary, means what is the condition? We have to divide it by K square, right? So by this condition we are going to simplify the circuit. That is, first consider the circuit only in the secondary side. These are the secondary part. What are the things in the secondary part? We are having resistance and reactance, that is R2 and X2. Together it is impedance Z2, right? It is connected to load impedance, that is ZL, and the voltage in secondary winding is V2 and the induced EMF in the secondary winding is E2 and the current flow in the secondary winding is E2. Right, now we have to transfer these components to primary side. Right, to primary side we want to transfer these components. If we want to transfer these secondary components to primary, means what is the condition? We have to divide this resistance and reactance by K square, and voltage and current we have to divide it by K. These are the conditions, right? So now then first we have to take R2 component, that is R2 divided by, we have to divide it by K square, right? R2 divided by K square, that is, we are considering it as R2 dash. Then what is the other component? Reactance, X2 divided by K square, we are taking it as X2 dash. Okay, and the impedance is that load impedance we are having is ZL, that also we have to divide it by K square, denote it as ZL dash. Then remaining component is voltage and EMF, right? We have to divide it by K. So V2 by K, that is denoted as V2. We are considering it as V2 dash. Then E2 by K, we have to consider it as E2 dash. Okay, by this transformation we have to replace the circuit of the secondary side. Okay, so here this R2 is transferred as R2 dash, right? R2 dash, and then X2 is changed as X2 dash, and ZL is changed as ZL dash. Okay, and then V2 is changed as V2 dash, that is equal to V2 by K, right? And E2 is changed as E2 dash, that is equal to E2 by K, which is equal to E1. How E2 by EK is E1? We have the transformation ratio equation. K is equal to E2 by E1, which is equal to N2 by N1, which is equal to I1 by I2. We all know this transformation ratio equation, right? From this equation, take only K is equal to E2 by E1. Therefore, E1 is equal to E2 by K, right? So we have considered E2 by K is equal to E1. So we are writing E2 by K is equal to E1. Okay, now we have transferred all the components, all the secondary components in different manner. Okay, so now we can connect this secondary part, this secondary circuit with the primary circuit of the equivalent circuit of the transformer. Okay. So now I have drawn the both primary and secondary side. So this is the primary side. I have connected the secondary, replaceable secondary components here, that is R2 dash, X2 dash, ZL dash, and the current flows in the primary winding is I1, and the additional current flows for the load condition is I2 dash, and these are the resistance and reactance in primary side. The supply voltage is V1 and the induced EMF is E1, right? And for no load condition I0, it has two components, IW and I mu, for resistance R0 and X0. Okay, so here I have connected both primary and secondary together. From this we can understand that resistance and reactance are connected in series, right? Resistance R1 and R2 dash are connected in series, and the reactance X1 and X2 dash are connected in series. Okay, now we can add these two resistance and these two reactance, right? So here, what are the resistance connected in series here? R1 and R2 dash. So therefore, R1 plus R2 dash, considering it as sum of R1 and R2 dash is R01, and reactance X1 and X2 dash is equal to X01. Okay, so what is R2 dash here? R2 divided by K square, we have seen earlier, and X2 dash is X2 divided by K square. Okay, so now we can replace, instead of R1 and R2 dash we can use one resistance, that is R01, and instead of X1 and X2 dash we can replace the reactance as X01. I have replaced here, that is, see here, both resistance R1 and R2 dash are together called as R01, and X1 and X2 dash together we call it as X01. Okay, now I have drawn the simplified equivalent circuit by transferring the components from secondary side to primary side. Okay, now if we want to transfer the components from primary to secondary, means what will be the equation? Here R01 is equal to R1 plus R2 dash, right? R1 remains constant, only secondary component will change. So primary to secondary means which component will change? The primary component will get changed, right? So therefore R02 is equal to R2, secondary component will remain constant, R2 plus R1 dash, and X02 is equal to X2 plus X2 dash. Okay, so what is R1 dash and X2 dash? If you want to transfer the component from primary to secondary, means what is the condition? The resistance value and reactance value should be multiplied by K square, right? So therefore R1 dash is equal to R1 into K square, and what is the value of X2 dash? X2 dash is equal to X2 into K square. Okay, these are the equations when we are transferring from primary to secondary. By this equation we can draw the simplified equivalent circuit. Okay, so this is the simplified equivalent circuit of transformer. Hope you all can understand this topic. Thank you, students.